Did you know our Milky Way galaxy, along with nearly 100,000 to 150,000 other galaxies, is being pulled toward a region known as the Great Attractor? Inside the Laniakea Supercluster lies this mysterious area. And along with our own galaxy, many others are racing toward it at a speed of about 600 kilometers per second, or 373 miles per second. But because of its position in the sky, it's incredibly difficult to study. Still, with new technology, astronomers have started uncovering more about this strange and powerful region, and the results might surprise you. Because the Great Attractor isn't just pulling, it's also being pulled by something even larger. And in this cosmic tug-of-war, there's also something else out there that's actually pushing us away. If you want to know how all of this connects, make sure to watch the full video. But before we start, I just want to say thank you guys for asking me to make a video on this. I really appreciate it. In the late 1970s and early 1980s, astronomers Donald Lynden Bell, Sandra Faber, and Roger Davies, along with several others, were studying the peculiar velocities of galaxies, the part of their motion not explained by the general expansion of the universe. Astronomers first noticed this strange movement when they began mapping the motion of nearby galaxies. Something didn't add up. Galaxies weren't just moving away from each other as the universe expanded. Instead, many of them, including our own Milky Way, seemed to be drifting in a particular direction toward a region in the sky that didn't match the known distribution of matter. This discovery came from detailed measurements of the cosmic microwave background, the faint afterglow of the Big Bang. By studying slight temperature differences in this background, scientists realized that our galaxy wasn't stationary. It was moving at incredible speed through space. But the question was, why? The data showed that the Milky Way and thousands of other galaxies were being drawn toward a massive concentration of matter located roughly 150 to 250 million light years away, in the direction of the constellations Norma and Triangulum Australe. This mysterious region became known as the Great Attractor. But even as the evidence grew stronger, one big problem remained. No one could actually see what was there. It's mainly because the Great Attractor sits in a part of the sky that's almost impossible to observe directly, a region astronomers call the Zone of Avoidance. This zone lies along the plane of our own Milky Way galaxy, where thick clouds of gas, dust, and countless stars block most visible light from beyond. It's like trying to look through a bright fog with a flashlight. The glare from our galaxy hides everything behind it. For decades, this made the Great Attractor nearly invisible to optical telescopes. Scientists could measure its gravitational pull, but they couldn't actually see what was causing it. It was like knowing something massive was hiding behind a curtain, but having no idea what it looked like. Then came a turning point in the early 1990s. Using radio, infrared, and X-ray observatories such as the Parkes Radio Telescope in Australia and NASA's Infrared Astronomical Satellite, astronomers finally began peering through the dense dust of the Milky Way. These instruments could detect wavelengths that pass through regions where visible light is blocked, revealing what had been hidden for decades. And what they found was astonishing. Clusters of galaxies and enormous cosmic structures lurking just beyond our view, including the massive Norma cluster, believed to be near the heart of the Great Attractor itself. This was the first real glimpse into the Great Attractor's neighborhood, but what scientists found there raised even more questions than answers. It isn't a single object like a black hole or a galaxy. It's a gravitational anomaly, a vast region of space where the combined gravity of thousands of galaxies, clusters, and dark matter is pulling everything nearby toward it. At the center of this region lies the Norma cluster, one of the most massive galaxy clusters in the nearby universe. It sits about 200 million light years away from Earth and contains thousands of galaxies, each with hundreds of billions of stars. This dense region appears to be a major contributor to the gravitational pull we feel. But here's where things get more intriguing. Our galaxy isn't alone in its journey. Every galaxy within the Laniakea Supercluster, the giant cosmic web that our Milky Way belongs to, is flowing toward the same point. Imagine a slow but unstoppable current in space, drawing everything within hundreds of millions of light years toward one invisible destination. Yet, even with the Norma cluster and its surrounding galaxies, the gravitational force there doesn't fully explain the speed and scale of this pull. That meant something even larger, something beyond the Great Attractor itself, must be at play. That mystery deepened when astronomers found out that the Great Attractor itself was actually getting pulled towards something even more massive in that same direction, the Shapley Supercluster. Located roughly 650 million light-years away, the Shapley Supercluster is one of the largest concentrations of galaxies ever found in our nearby universe. It contains more than 8,000 galaxies, grouped into dozens of clusters, all bound together by an enormous amount of mass and gravity. When scientists recalculated the cosmic flows, they realized that the Great Attractor isn't the ultimate destination. Instead, it appears to be just a waypoint on a much larger gravitational highway, with the Shapley Supercluster acting as a dominant pull farther down the line. But here's the twist. While something is pulling us in one direction, another region of space seems to be pushing us from the opposite side. A vast, nearly empty region of space called the Dipole Repeller. Unlike the dense clusters we've talked about, the Dipole Repeller isn't filled with galaxies or stars. It's a cosmic void, a region of extremely low matter density. Because gravity pulls on mass, the absence of it in this region effectively causes nearby galaxies to move away, giving the appearance of a push. The Dipole Repeller lies roughly 200 million light-years from the Milky Way in the direction opposite the Great Attractor. Together, the pull of massive clusters and the push of this cosmic void create a sort of gravitational tug-of-war, guiding the motion of galaxies across hundreds of millions of light-years. When you zoom out even further, this motion helps define the boundaries of our Laniakea supercluster, a sprawling cosmic structure containing roughly 100,000 to 150,000 galaxies. It's part of the cosmic web, where filaments of galaxies stretch across the universe and enormous voids separate them. From this perspective, our galaxy is not just floating in space. It's riding a vast, invisible current shaped by both attraction and emptiness. Every galaxy's motion is influenced by a delicate balance of these forces, showing us that the universe is not static, but a dynamic, interconnected system on an unimaginable scale. It's a reminder that even our own Milky Way, which feels so immense when we look up at the night sky, is just a tiny part of a much larger cosmic dance, a dance we are only beginning to understand. And that's the story of the Great Attractor and the cosmic forces shaping the motion of our galaxy. From the Norma cluster at its heart to the massive Shapley supercluster pulling it onward and the mysterious push from the Dipole Repeller, the universe is a dynamic, interconnected web more incredible than we can imagine. If you enjoyed this journey through space, make sure to like, comment, and subscribe. And if you have other cosmic mysteries or mind-blowing phenomena you want me to cover, drop your suggestions in the comments. A huge thanks again to Ana Bradadas and Felicity Keynes for inspiring this video. You guys rock. Until next time, keep looking up because the universe has more secrets waiting to be discovered, and I'll see you in the next one.